Okay, y'all. We just did problem 227, and it came out all pretty and even, but most of these, when they have a leading coefficient, won't come out pretty and even. So we're going to do problem 223. I'm deliberately doing them out of order. We're going to do problem 223. And we're going to use our flow chart. It might be helpful to you to have the flow chart open on your screen if you didn't print it out. Okay, so the top instruction says check the left-hand side of your equation. Is it already a perfect square trinomial? Rearrange if necessary. Okay, so I look at the left. It's not a square because of 3. So I'm going to rearrange. And I'm going to move my negative 12x over there and make it a positive 12x. I know it's not a PST because of the 3. 3 is not a square. So I know I'm following the no side. It says move the constant to the right. Well, the constant's already on the right. That's why I didn't move it back over here, because I would have had to turn right around and bring it back. So it was not a PST because of the 3. I moved it over to the right-hand side of the equation. I throw it over. Now it asks me this question in the green box. Is the coefficient of x squared equal to 1? The coefficient of x squared is 3. So the answer to that question is no. So I follow the flow chart. Here was the question. Is the coefficient of x squared 1? I answered no. So I follow over here to the no. And then it says factor the coefficient of x squared out of the x squared and x terms. You will now have a number and a parenthesis. Okay, so take my 3 and factor it out. As long as it goes even, things are kind of nice. We'll eventually have to do one where it doesn't go evenly. But I pulled 3 out of 3x squared and it left me with x squared. I pulled 3 out of 12x and it left me with 4x. Then I come back to my flow chart. And I did this step right here. So I follow the blue arrow and it says divide the coefficient of x by 2 and square that number. Divide the coefficient of x by 2 and square that number. So the coefficient of x is 4. 4 divided by 2 is 2. 2 squared is 4. This step told me to divide the coefficient of x by 2 and square that, and I did. Now I follow the blue arrow back over here, and it says put that number inside the parentheses. Alright, so let's do it step by step. Put that number 4 inside the parentheses. Then it says multiply it by the number in front. 4 times 3 is 12. And add that new number, which is the 12, to the other side. So add 12 to the other side. Because what I just did here was I added 12 to the left. See where my finger and my pencil are. 3 times 4 is 12. So I add 12 to the right. Then following the blue arrow, simplify the right side by combining the two numbers on that side. 38 plus 12 is 50. Following my instructions, factor the parentheses by PST. So factor the parentheses by PST. That's an x, and the square root of 4 is a 2, and it's always the sign of the middle. So I factored the left by the PST. Now follow my flow chart. Divide both sides by the number in front of the parentheses. Divide this side by 3. Divide this side by 3. Okay. Now I know that that does not go evenly. I'm well aware. This one's going to be just a little p-dab harder. Okay. So I follow my flow chart. I divided both sides by the number in front of the parentheses, which was 3. I follow across and up, and I come to this box in yellow. Take the square root of both sides. Put a plus or minus in front of the number on the right side, so you will have two answers. Okay. So, square root of the left, the square root of x plus 2 squared is just x plus 2. Square root of the right, remembering to put a plus or minus in front. Okay. Then it says write two baby equations. But before I do that, I can already see an added step I need on my flowchart. I've been tweaking on this flowchart for about 3 years. Okay. Right here, and I will add it in before the next time I print this one, but I'm not going to print another. If you ask me to print one, I'll see if I can't get it fixed. The problem is I'm running out of room on my flowchart. But after this yellow step, right in here, if you've already printed it out, it should, we have a step here that I've not put on there that I need to rationalize if necessary. Rationalize if necessary. Well, let me explain to you what rationalize means. Rationalize means make a number rational. Okay? Actually, we'll make it even better. Rationalize the denominator if needed. Okay, rationalize the denominator if needed. Okay, what do I mean by that? Right here, I have a square root of 3 in the denominator. The square root of 3 is an irrational number. I need to make it rational. The way you rationalize a number that is irrational is you multiply it by its twin. Okay? So the square root of 3's twin would be another square root of 3. But whatever I do on the bottom, I must also do on the top. This is what my niece calls a fancy 1. You have already used a fancy 1 in this chapter when you did imaginary numbers. This is a fancy 1. We cannot have i's in the denominator. We also can't have square roots in the denominator. So I multiply by a fancy 1 of the denominator. Now let's see what happens. We get plus or minus the square root of 50 times 3 is 150. The square root of 3 times the square root of 3 is the square root of 9, which is 3. And now it is no longer irrational. Okay? So we rationalize the denominator, and then we are going to simplify the square root if possible. Simplify the square root if possible. Okay? So, can I simplify the square root of 150? 150 is 15 times 10. 15 is 3 times 5. And 10 is 5 times 2. So yeah, I can simplify it. I can pull out a 5. When I pull it out, it goes between the plus or minus and the square root symbol. 3 times 2 is 6. So now I am to here. Let me go through one more time what I did. I cannot have a square root in the denominator. So I have to multiply the denominator by its twin, another square root of 3. Square root of 3 over square root of 3 is a fancy number 1. So it doesn't change the numerical value, it just changes the appearance. Okay? Then the square root of 3 times the square root of 3 was the square root of 9, which is 3. Squaring square roots cancel each other. The square root of 50 times the square root of 3 is the square root of 150. Then I factor tree 150 to be 15 times 10, which is 3 times 5, and 10 is 5 times 2. I have a pair of 5s, so I can pull it out. I pull it out between the plus or minus and the square root symbol. The 3 and the 2 do not have a pair. They have to stay inside. So plus or minus 5 on the square root of 6 over 3. All right, so now, back here, write two baby equations. So let's see what they look like. X plus 2 equals plus 5 on the square root of 6 over 3. X plus 2 equals negative 5 on the square root of 6 over 3. Okay, here's the plus one, and here's the minus one. Okay. Write two baby equations. We did that. Solve both baby equations, remembering to put a constant in front of any square roots separated by a plus or minus. Okay, and I'm going to add an instruction here. Get a common denominator if needed. We're going to need one on this problem. Get a common denominator if needed. Okay, so solve this equation. I subtract 2. My instruction box says remembering to put a constant in front of any square roots separated by the plus or minus. So that means that 2 is going to go there, and it's going to become a negative 2. That 2 is going to go there and become a negative 2. So let me write that. Now I'm deliberately hanging the plus out there in the air. I'm deliberately hanging the minus out there in the air, because really what I've got, oh sorry, typo there. Make sure y'all fix that. It's got to be a negative 2 when you move it over. These are two pieces. They're separated by a plus. These are two pieces. They're separated by a minus. The instruction I added said get a common denominator if needed. I need a common denominator. Now guys, this problem is difficult, okay? No doubt it is difficult, okay? Lots of steps. That's why the flowchart is useful. And I even last year let them use the flowchart on their test, and this year, since we're distance learning, of course you get to use flowchart. Okay? What is the common denominator of 1 and 3? So what I'm asking you is, what is the smallest number that 1 and 3 both go into? And you should tell me 3. Okay? So I'm going to have all denominators of 3. Well, this one already has a denominator of 3, so it doesn't change. This one already has a denominator of 3, so it doesn't change. But this one has to change. I multiplied the 1 times a 3 to get a 3, so I got to multiply the negative 2 times a 3, which is going to give me negative 6. Now this is exactly the same number because it was the same baby equation on the left. Okay, now I have a common denominator, so I combine the numerators. When you have two fractions that have the same denominator, you just add the numerators and put it over that denominator. They're not like terms, so I can't actually do any more adding other than this. Okay. Now, last step says put your answers in these guys. I've got one very important point to make about this one. I've got one super important point. You might want to write it down. You can only reduce if all three numbers outside are, hang on a minute. First Baptist, this is Faith. If you'll let me finish this video, I've got 2 seconds, and if I stop it, it'll make me start all over again. Just give me a few seconds. Bye. Okay, let me finish this one, guys, and then my daughter is here with me. Lunch. Okay. You can only reduce if all three numbers outside the square root are divisible by the same number. So look at my numbers outside. I have a 6, a 5, and a 3. 6, 5, and 3. I can only reduce if all three of them are divisible by the same number. 6, 5, and 3 are only divisible by 1. If this was 6, 3, and 9, I could reduce. Or if it was, any other three numbers that were all divisible by the same thing. But 6, 5, and 3 are not all divisible by the same thing, so I cannot reduce. So that ends this video on problem number 223.